Okay guys, the question we are given, the first question numerical is quite large, don't worry, just read it out. A spherical capacitor has inner sphere of radius 12 cm, outer sphere of radius 13 cm, and the outer sphere is Earth, inner sphere is having a charge 2 microcoulomb. Now the space between them is filled with a dielectric with the constant 32, and you are asked 3 sub questions. See, I have drawn the question figure again already. So this is your inner sphere A and this is your outer sphere B. A is charged with a positive charge. So B's inner side will be having induced negative charge and the outer side will be having induced positive charge. Since B is earthed, electrons flows from earthing and this positive charge can be neutralized, right? So now B will be having negative charge, A will be having positive charge. Guys, I am going to do this problem with just expression forms, that is RA, RB, etc. I am not going to do the numerical values. That should be done by you as a homework and you guys have to substitute it. Clear? Now, let's move on. So, inner sphere is having a radius RA and the outer sphere's radius is RB. This much is clear from the figure. See guys, since B is earthed, its potential will be 0, right? Now, whereas in the case of VA is in the presence of two spheres, that is B as well as A, right? So, VA is equal potential, or the potential, we know the equation is V is equal to KQ by R. So, due to the A sphere itself, the potential at A will be KQ by R, but B is producing another potential, that is minus KQ by R. So that net potential at A is KQ by R. It is plus, right? Plus minus KQ by R. So plus and minus comes, it becomes minus itself. So it is KQ by, this R is RA, this R is RB. RA minus KQ by RB. This much is clear? Right. Now in this case both KQ is constant, I will take it outside, 1 by RA minus 1 by RB. So I can write VA is equal to KQ, cross over this, that is RB minus RA divided by RA RB. Clear? Now what happens is, you are asked, second part of the question, let's move. What is the potential of the inner sphere that you got? As VA, you got the answer, right? VA is equal to RB minus, or KQ into RB minus RA by RA RB. Right, this is the expression for potential difference or potential of the inner sphere. That much has been asked. Let's move on. Now your question, first part of the question is determine the capacitance. Capacitance means this is an outer sphere, this is an inner sphere, so it is just like two plates. Just the shape has been changed, right? So you, for calculating the capacitance, you require the potential difference between these two plates, that is VA minus VB. So what is VA minus VB, guys? What is VA minus VB? VB is 0, so VA minus VB is VA itself. So this is the potential difference between the two plates. Clear? Now what is the question again? You are asked what is determine the capacitance. So C is equal to Q divided by VAB. That is potential difference between VAB. So Q divided by VAB, I am going to write this value KQ RB minus RA whole divided by RA RB. Now RA RB goes up, so and Q can be cut off, so that becomes RA RB divided by RB minus RA, and 1 by K is there, right? So this is the capacitance of the entire system, 1 by K into RA RB divided by RB minus RA, right? Now we'll go for the last section of the question, that is you are asked compare the capacitance of the capacitor with an isolated sphere, right? So you are asked what will be the capacitance of an isolated sphere. So you require an isolated sphere, means there is no charge, or it is not connected with anything else. So C part. So in the case of isolated spheres capacitance calculation, you require the total charge for an isolated sphere divided by potential of the isolated sphere. So what will be the potential of isolated sphere? It is normal KQ by R. Right, you just substitute the value over here, so it becomes Q divided by KQ by R. QQ cancels, it becomes R by K. right? I hope it is clear. So what is R by K? What is K? R divided by 1 by 4 pi epsilon naught, or it is 4 pi epsilon naught R. So this is the capacitance of a isolated sphere. This equation you have to by heart. That is capacitance of an isolated sphere. Clear? Let's move on to the next problem. Now, next question will go on with the capacitance circuit, guys. Right, suppose some of the NEET papers have this type of questions repeatedly asked. That is, you will be seeing a figure like this. I don't know if you have seen or not, A and B. And you will be asked what is the equivalent capacitance of the scenario. How would you do it? It's very simple, guys. This is A, right? So this point also will be A, and this point also will be A. This point is B, means this point also B, and this point also B. Clear? So I'm going to move from A to B, then B to A, then again A to B. Right? So A and B form a parallel plate. Right? Then B and A again form a parallel plate. Right? So A and B. So between B and A and another parallel plate. Right? And again it is A and B, so another parallel plate. See, it's a simple one. So you have three capacitors, let's say all of them are having C value CC. So it is C, C, C. So it is 3C. It's very easy, right? I hope you understood the concept of it. Similarly, let's ask a different question. You are having the circuit like this, right? Okay. And you are having a B terminal like this. This is A and this is B terminal. Now how would you solve this one? Move by the same method. This is A, this is also A, but this is not B. B is here, right? So let's name this terminal as 1, so that this terminal becomes 1 and this becomes 1. Now how would I point or give this is A, then 1, then B. Between, you are going to move from A to 1, so A to 1, right? Then 1 to A, 1 to A, right? Then you are going to A to 1 again, so then A to 1 again, a capacitor. Then you are moving from 1 to B, so 1 to B, right? Now you can calculate the equivalent capacitor by yourself, right? This will be 3C in series with C, right? So 3C in parallel to, series means 3C into C divided by 4C. You can cancel. The equivalent capacitance is 3C by 4. You remember, right? When two capacitors are in series, it is 1 by C1 plus 1 by C2, right? 1 by C equivalent. Or you can write it as C1 C2 divided by C1 plus C2. I did by this method. Clear? Right? This type of circuits are usually seen. Now what happens? The circuit is a little bit altered. That is, we are given a circuit like this. This is A, this is B, B, but here there is a dielectric medium, B, right? This is BB, this becomes AA, right? I'm not going to repeat it, guys. Now I write A and B. So I move from A to B capacitor, the B to A capacitor. Then again A to B a capacitor, but the thing is there is a dielectric medium. Suppose the dielectric constant is K. So this is C, this is C, this will be KC, and both three of them are in parallel, means C plus KC. It becomes what? 2C plus KC, or C into 2 plus K. That is your equivalent capacitor, right? This and all are simple if you understood the concept. Now the different type of questions which will usually come in NEET examination, right? That is with dielectric. Now suppose you are given a cell like this and you are filling the dielectric with two dielectric, that is multiple dielectrics are filled, right? So and their area is A, this distance is D, but this much half distance is filled with another dielectric, and this is another D by 2. Right, I will write it with another pen. This is having K1, this is having K2 dielectric constant. This much clear? So the equivalent is actually, these two are like two capacitors, right, in series. This is C1 and this is C2. C1 is due to K1 per dielectric and C2 is due to K2 dielectric, right? And see guys, D by 2, both of them are having D by 2 distance, but the area is A, right? So C1 can be written as what? K1, right? Its dielectric is K1, this dielectric is K2. K1 into A epsilon naught by D by 2, whereas C2 will be equal to K2 A epsilon naught divided by D by 2. C1 I can write it as 2K1 A epsilon naught by D, and C2 will be written as 2K2 A epsilon naught by D. I hope it is clear. Now these two capacitors are in series, so how can you calculate the resultant equivalent capacitance? That is C1 C2 divided by C1 plus C2. So I just have to multiply this guys, 2K1 A epsilon naught by D into 2K2 A epsilon naught by D whole divided by, add these two guys, 2K1 A epsilon naught by D plus 2K2 A epsilon naught by D. In both these conditions I am having A epsilon naught by D common, right? So I will put this guy out and 2 also. So it is 2K1 A epsilon naught by D into 2K2 A epsilon naught by D whole divided by 2 A epsilon naught by D, and in bracket there will be only K1 plus K2. I hope it is clear. So I can remove this two parts, right? So the entire thing will be having another 2 so it becomes 2K1 K2 A epsilon naught by D into K1 plus K2. This is the expression when the dielectric is in series. Clear?